Today, you already know that there are 3D printers that are commercially available, and the materials usually used in printing are metals, plastics, and resins. But recently, researchers in Carnegie Mellon University were also experimenting on 3D printers that can print soft materials. They want to extend 3D printing to a new class of materials for making objects that people would interact with. The features of this new 3D printer are that instead of melting a material to form the model, yarn is extruded to make the soft cuddly objects. It works like a sewing machine because it also uses a needle to entangle the soft material to the cloth or any base in which the threads are usually attached when sewing. Thus, the products are similar to hand-knitted versions because yarn is kind of thick as compared to threads. The 3D printer for soft materials works almost like an FDM 3D printer in a sense that it uses a software that translates the sketch drawn from a computer onto a series of G-code commands that will control the machine and its direction of printing. The 3D object being printed will be sliced into thin layers of material, and the printer will print the material from the bottom layer up to the top layer. The difference between the 3D printer for soft materials and the 3D printer for hard materials is that there is a print head that moves the felting needle up and down towards the incoming yarn, and it will penetrate up to a certain distance below the previously printed fibers. By piercing the incoming yarn and pushing the needle down the layers below, the yarn will be entangled with the layers below by the felting needle. The feed lock will regulate the entry of yarn. The server motor controls the entry of the yarn. The stepper motor behind the plate controls the movement of the needle, and the end stop switch is used to establish a home position for the rack. In addition to that, it is also possible to embed electronics and other fabric-based objects such as clothing for interactive devices through this 3D printer. Soft robotics is one of the greatest goals of this technology. By being able to embed actuators and sensors in soft materials, it is possible to create a soft robot with flexible parts that can make the robot more enjoyable for people to interact with. The advantages of this technology are that one can easily fabricate any virtual design, but that is not completely possible today because there are still certain difficulties in this technology. These problems are still being remedied, such as the sewing of complicated designs with spaces inside for the object to be embedded in. But given that the 3D printer is developed enough, it is possible to manufacture objects more efficiently in terms of the amount of manpower needed, which will be reduced through this technology. Also, one can customize his or her designs from a wide range of soft objects that can be printed, such as clothes, toys, shoe designs, and accessories. If yarn was made possible to be a material for 3D printing, then perhaps abaca fibers could also be used to print products that are made of it, such as the chair you see here, this basket, a slipper, and other accessories. Aside from interactive objects, the 3D printer can also be used for customized decorations, such as rugs and ornaments, just like the Christmas tree you see here and this little Mario head toy. Filipino innovators can also take part in the ongoing researches on 3D printing of soft materials. Currently, 3D printers that can connect hard and soft materials are being developed. Researchers are working on embedding electronics or circuits in fabric-based objects. Soft robotics is one of the possible products for this, but embedding actuators and sensors in fabric have a lot of difficulties in that the needle may hit the circuit while printing the fabric that will wrap around it. More research needs to be done, therefore, in developing circuits, actuators, or sensors that can be embedded in 3D printed soft material. This is a relevant patent to this technology. It is basically about a mechanism for 3D printing of different kinds of materials, mainly soft and hard, combined into one 3D printer. Examples of hard materials are ABS plastic and PLA, and also high-density polyethylene. As for soft material, the material is usually thermoplastic elastomer. Thermoplastic elastomers are flexible and they have a low modulus of elasticity, so it can be easily stretched as compared to hard plastic. In figure 4, we see two feed channels here in C1 and near B3. CD is the strip of solid material in solid form wrapped around a rigid wire for support. I think this is what they call the train sole, but when I look at it in the internet, I couldn't find any definition for it. Anyway, the soft material as shown in figure 2 will bulge upon pressure, so there is a special feed channel for it that will allow space for bulging. One of the feed channels will close if the other feed channel is open, so the two plastics cannot enter the melting chamber at the same time. When pressure builds up in the melting chamber, the molten plastic will be extruded from the nozzle here below, forming the 3D printed material. Once it cools down, it will be in solid form again. The wire here will end up in the CH area. The CT is a fusing for the train sole. The fusing for the train sole is used when the wire is to be melted instead of ending up in the winding device for the spent train sole.